What we actually really need to do is get the performance of a rocket into something that is as efficient and usable and scalable as an aircraft. We need to, marry these two.
Welcome back to another episode of a Kiwi Original. Today on the show I'm joined by Stefan Powell, who is the Chief Technology Officer for Dawn Aerospace, a company that is leveraging the fact that space is the new frontier. And although it seems super new, it's already worth $1.69 billion to the New Zealand economy. And this is a company doing some pretty exciting things. So first of all, Stefan, welcome to the show.
Yeah, thanks for having me on, Ryan. It's great to be here.
Now, a sentence I read on your website said that you're doing suborbital flights from Oamaru Airport, or at least you've got permission to do suborbital flights. How far up is that, and what benefit does that give Dawn Aerospace being able to take off and land at Oamaru Airport?
Yeah, so suborbital is, well, actually almost any flight is defined as suborbital as long as it doesn't go all the way to orbit. So for us, that means, you can see on the website, there's some diagrams. Our target for the Mark II is to be able to go to space twice in a day and to be the first vehicle to ever do that. So that, the commonly accepted border to space is 100 kilometers. So that's what we're targeting. So we should be able to exceed that. And what advantage does flying out of Oamaru have? Well, actually, Oamaru is just one of many places that we can fly from. I mean, the great thing about being an aircraft is that you can utilize pretty much any airport that has a long enough runway and has reasonably clear skies. You probably don't want to fly out of Auckland International just because there's a lot else going on there. But we're talking to many airports all around New Zealand. Pukaki is another one that we're already had some discussions with. The virtue of being an aircraft is that you can use existing infrastructure, you can integrate with existing airspace users. You don't have to be a burden on everyone around you. They don't necessarily have to get out of the way.
So I guess that what you're kind of linking into there is that we all understand what planes do. They will take you up into air and then land you again in the most basic kind of framing. What's different about the Dawn Aerospace vehicle or plane, if you like? Like, what does it need to do, and how is it built in a way that it can achieve things that a cargo plane or a passenger plane can't do?
So a cargo or passenger plane is really optimized for flying. It really uses the air to create lift and go from one place to another. Our space plane really only uses lift down low. So, to take off, to get off the ground, and when it's coming back down from space to, so that it doesn't hit the ground like a ton of bricks, like a rocket would. It uses the air to slow itself down and glide back and land. Aside from that, once you've taken off and you essentially want to just go high and fast, you fly pretty much the same way as a rocket. You fly quite steeply up, and you keep on going until you get to space. It's able to do that because it is still majority fuel on board, just like a regular rocket does. It's still built to very high standards with very lightweight materials like carbon fiber, and it doesn't have nearly as much payload on board. Not nearly as much cargo as what a regular aircraft would have on board. So that all means that you still get the performance of a rocket. You've still got enough get up and go to actually go to space.
And once you get there with one of your craft, let's say the Mark II Aurora, which is the current version, the payload there is 4 kilos, which is a couple of MacBook Pros, maybe, 1.5. It doesn't sound like a lot, and space seems like a pretty lonely, isolated place. What do you want to put in? What's the value that you can put into a 4 kilo box, and why is that a value to both Dawn Aerospace and to New Zealand?
Yeah, so there's actually a really common form factor of satellite that's been built to the small standard. They're called CubeSat, so that would be a 3U CubeSat or three 10 by 10 by 10 centimeter blocks. So it almost forms this little like shoebox size thing. And there's lots of companies building hundreds of these actually as satellites to fly around in space. Now, the Mark II Aurora won't be able to go into orbit, so it won't be able to take one of these to space, but it is still a very interesting form factor to be able to test systems, to be able to put one of these CubeSats in a vehicle that's going to fly up to space and be in these representative conditions for short periods of time to be able to test a whole bunch of things. And the great thing about the Mark II Aurora is that you will be able to get this stuff back. It returns to where it took off from. And if anything did go wrong with the payload, or if they wanted to make some tweaks or optimize something, they can change things and go fly again the same day. So it gives them a very fast development cycle. They can test a whole bunch of stuff, make sure it's going to work before they actually fly to orbit. That's just one particular use case. There's a whole lot of other interesting stuff you can do with microgravity research, with atmospheric research. It flies perfectly through this area of the atmosphere that's too high for atmospheric balloons to get to, but far too low for satellites. And that part of the atmosphere is super important for how our climate models and weather models work. So, a country like New Zealand, that, a lot of our industry is actually primary industry. We're pretty dependent on the weather down here. Knowing what the weather is going to do, not just, short-term forecasts, but, long-term climate change stuff, that really gets informed by this high altitude data that can come from suborbital vehicles like the Mark II.
And when are you first likely to get something up there in that CubeSat format where you're going to leave it there? And if you're able to do these on a launch one more than once a day, how much of an advantage does that give you over an organization that's launching rockets that, even if they can get them back down to Earth, there might be weeks before they can recondition it to send it up again?
Yeah, I mean it's a total change to the operating model. You're no longer having factories produce huge amounts of hardware. You move to more like a fleet style operation. Like an airline operates a fleet of aircraft. They're not constantly building new aircraft. Sure, they replace them after 20 years or something, but you get literally thousands of uses out of them. That's the idea. That's kind of the hardware side of it. That's the hardware advantage. There's two other big advantages. Getting to space is kind of 1/3 the hardware, 1/3 the regulatory system that you work in, and 1/3 the infrastructure that you use on the ground. So being a plane, like I say, is much better hardware-wise. You get thousands of uses. It's much better from a regulatory perspective because you certify the vehicle to fly and you get a license to fly, as opposed to how a rocket is certified. It gets a launch license for that particular flight to deposit these particular things into orbit. That's something that we completely want to change. And thirdly, lots of companies end up building their own launch sites specifically for their rockets. And that's an extremely costly thing to do. Not particularly scalable either. If you want to move to doing thousands of flights per annum, you're going to need, probably hundreds of launch bases, and that's, well into the billions of dollars to be able to do that. As opposed to if you fly like an aircraft, it's not that hard to just go use an existing airport to do so. You not only avoid all the time it takes to build these airports, but the cost too.
How did you figure all of this out? Because within Dawn Aerospace, there's not just you. There's a team, and you've also got I think it's your brother James Powell, the GM. Was it the two of you that decided to launch this, or one of you and then the other one followed? Like, how did this go from being something that it was an idea through to learning the engineering behind it, which is no small feat on its own, and then joining what is a very small, it's like a very early stage industry, at least in New Zealand.
Yeah, definitely. It's a bit of a complicated story, I suppose, and it was really the meeting of two different worlds. So I studied over in the Netherlands, a university called Delft, Delft University of Technology, and they have a pretty vibrant student rocketry community over there, and they were doing some pretty cool stuff at the time. As part of a team of about 50, I was reasonably involved in the engine development of a rocket that we ended up launching from Spain and breaking some European records, and that was a ton of fun. But it was 5 years of engineering, building these big hybrid rockets, 1.5 ton thrust things. We blew up so many of these motors, and we learned so much doing it. We were able to just learn so quickly through failing, actually. It was just this great environment to be able to do that. And we found that we had this amazing team for developing new technology. There was about 12 of us in this engine development team, and actually 4 of them ended up joining us to form DARE. There was 4 of us in this group, and we originally tried to commercialize that engine technology, this relatively classic engine technology, classic rockets, pointy end at the top, fiery end at the bottom type stuff. And we unfortunately kind of failed at that as well. We didn't manage to commercialize it because it was just too expensive. It was just too laborious to build even these very simple rockets and commercialize it. Just like, for example, the launch range costs were like 40 grand per flight, and that was just not doable when the whole shebang was only really worth 100 grand to the customer, and 40% goes to just paying for the launch range. It was just never going to be commercially viable, and so we kind of realized that we needed a better way to do this. So I'd been doing this with 3 of my European mates. And my brother back in New Zealand had been working on in the aviation industry, doing all kinds of aircraft and helicopter modifications and exporting that around the world. He was kind of following our project, and I'd always be talking to him about it, nerding out on engineering stuff. And we kind of got to the end of this failed commercialization stage of this rocket technology, and we realized, like, hey, you actually really need to do is bring these two worlds together and get the performance of a rocket into something that is as efficient and usable and scalable as an aircraft. We need to, marry these two. And so we sat down and we figured out a way that we were actually going to practically do that. How are we actually going to do that under the current rule set? How are we going to do this in a practical sense, and crunch the numbers, and figured, like, hey, this is actually super doable. And actually that that New Zealand was probably the best place in the world to do it, because the way the Civil Aviation Authority works here is really great for doing out-of-the-box experimental stuff. It's second to none in the world. In fact, there's a whole bunch of aerospace companies that specifically come to New Zealand to do their aircraft certification and develop experimental vehicles. So yeah, we realized that this was just a match made in heaven.
And tell me about Hyperion, because I think that the bit in between the time you were in Europe and the time that you started Dawn Aerospace.
Yeah, so I worked for them pretty early on, and I actually did my master's thesis with them as well. So they really gave me a good base in space technology and understanding actual users in space and customers. They're a company that builds satellite components, mostly for CubeSats and small satellites, usually around ADCS systems. So these are the things that essentially the eyes and ears of the satellite, and the things that help the satellite actually turn around in space. So one of the things that they had me working on was propulsion for these small satellites. So that was something that we've yeah, that I started studying through my master's thesis and devising ways of making propulsion for them. Yeah, that was kind of the very early days, and Hyperion also helped us set up as a company, helped mentor us, and we've eventually kind of spun that technology out, and we developed some of these products together with them now. They're really experts in the electronics design and PCB manufacture and software. And the expertise that we now bring to the table as Dawn is the the more nuts and bolts chemical propulsion side of it.
Okay, now that makes sense. So what I'm building up in my mind here is that the European part where you were working on the engines, that was getting you to understand the construction of the engine, the propellant, the gravity, how do you get into space, all of those things. And then by shifting to Hyperion, you're starting to understand the product that's going to go up there. So the electronics, the actual CubeSat, the payload part, which is the valuable part to the client. And then Dawn Aerospace, you're actually creating the transportation to allow a company like Hyperion to launch more of their CubeSats into space on behalf of their clients. Have I summarized that correctly?
Yeah, that's pretty much the guts of it. I mean, Hyperion was really great for getting us to work with, real satellite operators, people that actually want to build satellites and use them. So it got us a heap of contact with them to really understand their problems, what actually drives their design, what makes them make decisions, and understand really what their problems were. And that was super key for allowing us to set up Dawn and giving us a good direction that was actually, that meant we're going to produce products that people actually want.
I read from their site some of the names of these products, and they're things like magnetometer, a CubeSat laser, something, a global navigation receiver, a gigabit detector. What's the benefit of having these types of capabilities up in space? So what does it allow us to do as a nation or as the human race that we can't do from just putting it on a high mountain somewhere?
So I mean, all those things that you read on Hyperion's website and ours as well, with all the propulsion products, these are essentially like components in your car, right? Like it's a steering wheel and this thing's the engine and this thing is the onboard computer, or the, and that laser thing, I believe, is the laser communication thing. That's something that allows you to talk to the ground, super high data rates, and without having to use radio spectrum. So they're all kind of, like the components of the vehicle. So then, the question is, well, okay, I know why a car is useful, but why is a satellite useful? And the answer is pretty complex, actually. There's a million things you can do with a satellite. Right now that stuff is mostly around providing some sort of service to Earth, whether it's taking photos or, Earth observation stuff, measuring sea level heights or carbon emissions, or just taking photographs and creating insights out from that, everything from tracking shipping containers to how many cars are in a competitor's parking lot, and assessing how well is their business going. There's all kinds of stuff, or where are icebergs, is the shipping lane open yet? So communications is becoming the next really big thing. So that's communications for IoT, as well as broadband internet from space. That's another big one SpaceX is working on in particular. And then even further out from that, you start to get to things that some people would see as more sci-fi, but these are really trillion-dollar industries that are coming, particularly in manufacturing from space. So space is this fantastic manufacturing environment. It's super clean. There's no gravity. There's heaps of energy available. Constant sunlight. It's really the perfect place to be manufacturing superjet drugs and semiconductor chip manufacturing, as well as super materials, and all this stuff is kind of in the early stages of being researched and actually demonstrated. And it's coming. In 10 or 20 years time, these could be trillion-dollar industries. and they're going to need serious transportation to space. You know, that's kind of the core problem that we at Dawn Aerospace see, that there's all this opportunity coming, and it's going to be really hard to utilize if the best way to get to space is still classic rockets. You know, we need a better way to do it. We need something that's going to be sustainable, you know, not just for the foreseeable future, but for the unforeseeable future.
Hey, just a quick interruption. Thanks for watching a Kiwi original. If you're liking this episode, then hit the notification button, and that means you'll see when every new episode gets released. We've done 40 already. We've got another 50 lined up. Right, now back to the episode. And if there is advanced manufacturing done in space, which is of interest to me, you know, running the Buy New Zealand Made campaign, because the majority of the businesses that we represent are manufacturers, right? So it wouldn't be too far a leap to imagine a Christchurch manufacturer decide to start using your services on a regular basis to set up manufacturing in space. But then you've got the problem of, let's say they're making something, now you've got to get that payload of manufactured products back, and at a 4 kilo payload limit, that's a lot of flights. What's the next evolution that you would plan, and what's the next payload that starts to make the idea of space manufacturing a little bit more feasible?
Yeah, so just to be clear, you know, the Mark II Aurora doesn't even go to orbit. So it's a 4 kilogram payload on a suborbital thing. So if you want to manufacture something in space, we'd start talking about the Mark III, which is going to be able to do to be able to get about 50 or 100 kilograms into space. So that's starting to get interesting. You know, you can take a lot of stuff up if you can do many of those flights. But the next evolution of space transportation is figuring out how to get lots of stuff back down. You know, currently the best way to do that is with capsules. They're basically single use. I mean, you can get a few uses out of some of them. What SpaceX is talking about, being able to reuse Dragon capsules. But it's very expensive, and it's not a particularly scalable way of doing it. So really the beauty of having a reusable space plane is that it's a fantastic research vehicle. Because it is a reusable way of accessing space, it's a great way to test new things and to, you know, research new materials that are going to allow us to actually return stuff from space in a reusable fashion. You know, the space shuttle did it to some extent with pretty much 60s, 70s technology. The X-37B is a really good example of a more modern space plane type thing that can actually return decent cargo from space. We think we can do a lot better than that again, and that starts with having a way to test these new technologies.
It's so exciting to hear you talk about this, knowing that this is a New Zealand initiative, that this is happening on New Zealand soil. I'm sure a lot of Kiwis listening to this will be thinking, wow, I didn't realize how advanced this was, and how it, rooted in reality it is, and how close it is to actually happening and becoming an industry. What for those that are listening and thinking, actually, this is something that excites me, that I want to get involved with, how could someone do that, either as a customer or as someone thinking over the next 5-10 years, or in high school now? What do they need to start learning in order to become actually valuable to an organization like yours?
In terms of the people that we hire, basically any sort of, you know, anyone who's studied STEM stuff is down the right track. So, you know, classic engineering is the best way. Of course, physics people as well, lots of computer sciences people. You know, this stuff is quite software heavy as well. So anything down those tracks is very useful. In saying that, I mean, education is important, but it's certainly not the only important thing. Having some sort of demonstrated track record of having built something. You know, if you're young, it can be simple. It doesn't have to be an expensive thing. It doesn't have to be a titanium widget that is super amazing. It can be, you know, programming your own computer game, or you know, doing something cool with Arduinos, or you know, anything in the domain that you're excited about and that you want to get into. There's no excuse for not getting out there and trying. If you can afford a smartphone, then you can definitely afford to show some initiative and teach yourself in the domain that you want. You know, high school and university really only goes so far. And actually, that was the great thing about Delft University of Technology, was that there were lots of student projects that you could get involved in. And I know there are similar projects going on at Auckland University and Canterbury as well, and lots of high schools too. You know, there's just get involved, just start doing stuff that excites you. That's the best way.
And I think that's that echoes there's a venture capitalist from the US who talks about knowing where technology and where businesses will go next. He looks at those who are the developers, the programmers, and asks them, what do you do outside of work? Like, what are you tinkering on? What are you curious about? Like, what are the things that you're just doing as kind of a side hobby? Because those are usually the things that then evolve in new and interesting ways. And it's not out of reach for you know, young Kiwis wanting to get into this. I saw there was, I think, something on your Twitter feed saying, you know, here's from MIT open courseware on studying rockets. Like, you can learn rocket staging or orbital mechanics for free. Like, you don't have to go to even university to know this stuff.
Yeah, exactly. Like, you know, there's so much information out there, and there's so many good ways to get into this. It's everyone has a chance to start reading about it and start doing it if they really want to. And, you know, like, so many of the early people that we hired, and, you know, all of the founders, we were doing this stuff before we were paid to do it. Like, you know, that's how into it we are. You know, when I always get these questions from investors being like, you know, what's going to keep you motivated? And it's like, you know, I was doing this for free, right?
That's classic. I mean, they got the similar story, but in a very different area. I interviewed business owners for a hobby for 18 months because I love doing it. I love hearing the stories, and now I'm getting paid to do it as part of my job at uncovering these stories. What's you're based in Christchurch, is that right?
Yep.
What's the ecosystem opportunities around Dawn Aerospace that if things were there, businesses or services that would help support where you're heading, what do they need to be, either in manufacturing or in general?
Yeah, like, certainly in specialist manufacturing, stuff is super useful. We use a fair bit of that. We're also pretty keen on having that sort of stuff in-house as well. You know, if we end up using a lot of something, we tend to bring it in-house just so that we can have it on demand when we need it. That's certainly helps our R&D process. But I mean, we're, in terms of how the outside world helps us, it's relatively similar to other engineering stuff. You know, we use lots of local machine shops. We use lots of general services, just like any other business does. In terms of the wider Christchurch aerospace community, Aerospace Christchurch is the name of actually a really great community that's set up by Mark Rocket. And he's got a group of people that organize these fantastic events every, you know, few months or so, and the whole aerospace community, or anyone who's keen on it, comes into one room, and there's great presentations just about whatever's going on, or whoever's working on a cool project. And it's a fantastic forum actually for people to just get together and nerd out on whatever aerospace or engineering stuff in general is going on. And that's a really great way to meet people, and yeah, that's actually a great service to us for sure.
And Stefan, for those that are listening that are outside of New Zealand, and you know, they want to invest in getting technology into space for some of those reasons you've mentioned, in terms of you know, computer vision, better tracking of things, better comms, better coverage, better ability to launch things on a, you know, more regular basis. What how do they engage with you? What's the pitch for them to be able to get a slot on either the Mark II or the Mark III Aurora when it comes about?
So are you talking about in terms of investors or in terms of customers?
Oh, customers, always the customer.
Yeah, great. Yeah, so we're already talking to customers. I mean, in terms of the in-space propulsion stuff that we do, so that's rocket motors that actually go on satellites and give them mobility in space. You can be a customer right now if you want. You go online and you add to cart and go buy now, and I'll send you a thruster in 6 weeks. So you can get involved just like that. No, but I mean, in all seriousness, we have quite a few customers there already, and we're shipping product to them. And that's really great. The Mark II Aurora is a little bit further away from commercialization. We are already talking to some customers who want to use it, and we have the first ones of them already lined up. But yeah, we're taking bookings for that now, and we'll probably start commercial operations on that in around about a year's time, once we're further through our development process. Because I mean, this is a vehicle that we want to be flying thousands of times, just because we do a lot of learning ourselves, and because it is an extremely useful research vehicle, not just for our own purposes, but like I said already, for all kinds of other scientific things you can do. So we want to open that up to the rest of the world and give them a chance to do world-changing science.
Simply amazing. Another podcast I was listening to, and I don't know if you've had a chance to, you probably haven't given how busy you are, is the 13 Minutes to the Moon podcast, which goes back over some of the original audio of getting America to the moon. And something I didn't realize from that was the average age in ground control of those looking after getting humans back from the moon was only 27 years old.
Okay. Shocking, right? I mean, like, that'd almost be like, oh my God, like, how could we do that? That's irresponsible, isn't it? But yeah, it's very surprising how people grow to what you ask of them. If you're going to give someone that sort of responsibility, they will grow to meet it. As long as you facilitate them and you give them what they need to be able to do their job, almost invariably they'll make it happen.
And here we are, almost 5 decades later, and there seems to, at least be in the US, there was a slowdown for a period of time. How quickly, with what you're doing, is this going to revolutionize space to actually achieve some of those things? Is it like kind of telecommunications where it's a few years, or is it like healthcare where it's a decade, or are you looking at things like, 12 months we'll be doing something, 12 months again it'll be 3 times better?
This is definitely a marathon. I mean, we're trying to run the marathon as fast as we can, but this is an industry that is going to be growing not just over the next 5 or 10 or 15 years, it's really going to be growing for the next 30 plus. Like I said, there's so much more that space could be doing for us. We're just scratching the surface. I mean, commercial entities have really only been getting into space for the last 20 years, just barely. SpaceX is just barely, not even quite 20 years old. And Blue Origin is the same. And look how much they've changed in 20 years. Like, okay, yeah, sure, that's a long time, but space has grown so much in that time, and it's going to keep doing it for sure. Yeah, so I mean, we are certainly trying to move as fast as we can, but this is also very difficult stuff. One thing that is really playing to our advantage, and something that I believe in quite strongly, is that we always set ourselves up to be able to fail. And it doesn't mean, as a company that the whole company folds, but it's the technology that we develop has to be robust enough that things can go wrong and you don't lose the whole vehicle or lose the whole project or have a major setback. Now that's really different to how rockets are launched. Countless times rockets have failed because one single minor thing goes wrong, or like a checkbox wasn't checked in software, or some minor thing happens and they lose the entire mission. Now with an aircraft, because there's redundant systems, because it has wings, you can have engines fail, you can have things go wrong, and you still get it back. You land the vehicle, you fix the thing, and you go fly again. That's really critical in letting us safely take way more risk. And the more risk you can take, the faster you can move, and the faster you can learn. And that massively helps your development cycles. You can just learn quicker. It's better.
I think that's something that's almost underappreciated, isn't it? That iterations and permission to fail means not only can you learn faster, but things like rockets don't have, like if it doesn't go right, it's pretty hard sometimes to, I would imagine, reverse engineer an exploded rocket that's 50 kilometers up in the air. Whereas at least if you can get your vehicle back down to ground, you can have a look through the software or the hardware and see what the root cause was and then re-engineer it for the next time.
Yeah, absolutely. That just makes life so much easier being able to get it back. Get so much more information if you're not, digging up pieces out of a crater, or, if they're on the bottom of the ocean, for sure.
And you don't need to bet the whole company. Like I think Elon Musk on one of his was down to, I think it was either he could, if he didn't land the rocket, that was it for his fortune. He had one more shot.
Yeah, I think that was the fourth flight of Falcon 1. Given, I mean, they had failed 3 times already, so they didn't bet everything on the first rocket or the second or the third. But by the time they got to the fourth, that was the last straw. But yeah, they made it work, and now it's a big deal for sure. So,
before we finish up, Stefan, I just wanted to give you an opportunity. Is there anything that I haven't covered, or anything that you want to share with the New Zealand audience that is probably pretty excited by this new space frontier that you're opening up?
No, just that we're lots of people ask us about, like, do we feel like we're super competitive with everyone else, or are we competing with SpaceX or Blue Origin, or aren't we daunted by this? And I think I just completely disagree with the idea that we're competitors. Perhaps in a commercial sense we are, but the reason that we've gotten into space, and I think lots of people get into space, Elon Musk included, is not because they want to make a lot of money. This is kind of the wrong industry for that, to be honest. We're doing this because we want to create this vibrant, fantastic future. And I don't much care if my ideas are wrong, as long as somebody else's are right. I just happen to disagree with them, but as long as one of us is correct, we all win. So that's kind of the end goal here, is a vibrant space economy, a vibrant future for all of us. Not that I'm right and they're wrong.
That's a great attitude to have, and it's almost something we need to have down on planet Earth as well. As we're all here, we've only got one planet, and that whatever we can launch or do in our own lives to help each other as well as ourselves means that we're more likely to lead fruitful and rich lives.
Yeah, absolutely. We're all on the same spaceship after all.
Exactly. Stefan, appreciate your time today. Thank you very much for giving us a bit of an insight into what you're doing at Dawn Aerospace, a bit of your own personal background and journey to date, and some of that advice for the next generation coming through on how to maybe start their own journey and joining New Zealand's space effort. And I really look forward to see and tracking your progress over the coming years. What a fantastic addition to New Zealand and also to the space industry. So I appreciate your time.
Great. Thanks for having me, Ryan.
Thanks, Stefan. This has been a Kiwi original brought to you by the New Zealand Made team. Thanks for watching. The New Zealand Made trademark is used by over 1,200 businesses in New Zealand. The New Zealand Made team licenses that trademark. Check if you're eligible at bynz.org.nz. If you feel that someone should see this, share it with them now. Otherwise, subscribe to youtube.com/bynzmade, and we'll see you on the next episode.